Hi everyone, today we are going to see the linear programming problems, that is model number 6 in SEM. This is a very basic model. This we almost we have seen this type of problems in inter level also, but for refreshment we are going to see the first basic model. This is applicable for inter also. What are all the steps involved in linear programming? The basic steps. Okay, the first step is decision variables. We have to decide what is the decision variables we are going to use in this problem, that is whether it is x1 or x2, a or b, or like that, or x, y, like that. We have to decide what kind of decision variables we are going to use. This is the first step. What is the second step? We are going to decide the objective function. What is the objective for the given problem, whether it is maximization of profit or minimization of cost. That is the objective. So what objective we are going to have for this problem, that is called objective function. Okay, next one is constraints. Constraint is nothing but our limitations. What are all the limitations involved in this particular problem? That is called constraints. Okay, so constraint we have to decide, and accordingly we have to write a equation for that constraints. And final one is non-negative. Non-negative is nothing but this physical quantities. What is the product we are going to, what is the product involved in this problem? The product can be a physical one, so it cannot be a negative value. So whether it is going to be a 0, we are going to make a product means it can be 1, 2 or 100, whatever it is, the number will be there. Otherwise, if you are not making the product means it is 0, so it should be greater than or equal to 0. So that is called non-negative. So it should not be a negative value. So that is non-negative things. So these are all the four important steps we having in this constraint. In this linear programming model. Okay, let's see the first illustration so we can able to understand this. Page number 427, the first illustration. A shopkeeper deals in two items. Okay, two items. One is wall hanging, other one is artificial plants. He has to invest 50,000. He is having a money of 50,000, so he can invest up to 50,000, and space is only up to 100 pieces at the most. He is having space for 100 products. Okay, only for 100 products. So one wall hanging or one artificial plant means he can able to store up to 100 pieces. Okay, one wall hanging or one artificial plants, whatever it is, whatever number it is, he can store up to 100 pieces only. So what the cost of the wall hanging and cost of the artificial plant is 450 and 200. Okay, for wall hanging it is 450 and artificial plant is 200. This is the cost, and he can sell a wall hanging at a profit of 80 rupees and artificial plant 37. So his aim to sell the wall hangings for 80 rupees profit and artificial plant for 37 rupees. So he can sell at the items, all the items. Okay, assuming that he can able to sell all the items he buys. Okay, the linear programming model in this thing we are going to maximize his profit. This is formulate a linear programming problem in order to maximize his profit. This is our aim. We have to maximize his profit. His aim is to have 80 rupees profit of wall hanging and artificial plant for 37 rupees. That is his aim. So for that aim, how we are going to maximize his profit. So accordingly, we are going to frame this linear programming problem. So, okay, in this, how much wall hangings? The cost of the wall hanging is 450. Artificial plant is 200. So one wall hanging cost is 450. One artificial plant cost is 200. But he can sell this for the profit of 80 rupees and this for the profit of 37 rupees. And how much he can invest? 50,000 rupees. So wall hangings, to buy wall hangings and artificial plant, he can money only up to 50,000. Up to 50,000 he can invest. Like that he can save storage space. So 100 items he can store. So this is the limitation. This is a constraints for this problem. So that is maximum he can invest 50,000 and maximum storage level is 100. So this is the limitation. Okay, here what are all the decision variables we are taking? Okay, let x1 be the decision variables. Okay, this is the x1 be the wall hanging and x2 be the artificial plants. So variables in this case is x1 and x2. Okay, what will be our objective function? Here he is going to maximize his profit. This is our aim. So the maximization of profit means we have to maximize this. Cost means we have to reduce it. So minimization for cost, maximization for profit. This is our always, this is the rule. So here our objective is to maximize. So we are going to write the objective function z, maximize z. What is the aim of his profit? Okay, in that question they are given the profit is for wall hanging is 80, for artificial plant is 37. So we can write 80 into x1. Okay, 80 into x1 of wall hanging plus 37, that is the profit for artificial plant, that is x2 is artificial plant. Here we have seen now, let x1 be the wall hangings, let x2 be the artificial plant. So for x1 80 rupees profit, for x2 37 rupees profit. So that is our maximization function. So z is equal to 80 x1 plus 37 x2. This is our objective functions. Okay, what are all the constraints we are having? Already I mentioned he can able to invest up to 50,000. That is his investment capacity. Like that he can store up to 100. That is his storage capacity. So this is our limitation, this is our constraint. So up to means less than or equal to 450 rupees cost. Okay, 450 rupees x1, number of wall hanging is x1 plus 200 rupees x2, less than or equal to 50,000. Up to 50,000 only he can invest. So that should be, the amount should be less than or equal to 50,000. That is the investment capacity. Okay, the number of wall hangings plus number of artificial plants should be less than or equal to 100. That is his storage capacity. That is limitation. This is investment capacity. This is the limitation for storage. So he can, the up to means we have to use less than or equal to. So he can store up to or at most, maximum they can invest. These words are related to less than or equal to. This much only, within that only he can able to invest. Within that limit only he can able to store. So less than or equal to. This is the constraint equation. This is the rule for constraint equation. Okay, here what are all the variables? x1 is the number of wall hangings and x2 is the number of artificial plants. That should be more than or equal to 0. That should not be a negative word. So the x1 is greater than or equal to 0 and x2 is greater than or equal to 0. These are all the main steps for linear programming. This is a very basic problem, and here we are making only what is decision variables, what is the objective function, or how to frame the constraint, and how to derive the non-negative things. Okay, these things, this is the very main basic steps for linear programming problems. Okay, decision variables we know, objective function maximization or minimization, and if it is maximization functions, the constraint equation will carry this simple, that is less than or equal to. Okay, so we can able to remember, if it is a maximization objective means we can, in constraint we can use less than or equal to. Okay, and non-negative factors means always greater than or equal to 0. These what is the decision variable we have taken? In that we put greater than or equal to 0. Okay, this is about the basics of linear programming problems. Okay, further in next videos we will see the graphical model. Okay, thank you.